Good morning, everybody. Welcome to the GTSgroup webinar on gSharp, our replacement for the PyAce calculation product. By way of introduction, my name is John Messenger. I'm the Chief Technology Officer with GTSgroup, and we'll be taking you through the presentation and demo today. This webinar is being recorded, and for all those that are in the webinar, we will send you a link later on so that you can access the recording, watch it again at your pleasure, share it with anybody else within your organisation. To start with, I'd like to just touch on a little bit of the background of PyAce, what it is, and why we've gone and built something to replace it. With me today is Richard May, who is the lead developer of our gSharp product. And both he and I will be available to answer questions later on. So the basic agenda for today's meeting is that we will talk a little bit about PyAce and gSharp, where they fit in. We'll walk through a demonstration with you on taking an existing PyAce calculation and converting it and migrating it over to gSharp. Following the demonstration, we will have availability for questions and answers. So without any further ado, let me start the discussion. A little bit about GTSgroup. We are real-time data solution specialists. GTSgroup has been in business for about 13 years now, and we are Australia's largest and most accredited Pi system integrators. We have a number of former OSIsoft people working for us, including myself, and many of you I do know from my OSIsoft days. So Pi is a key part of what we do within our business. GTSgroup it actually consists of three companies. These companies are GTSgroup Australia, which is our project delivery services, real-time data solutions. Ghost Technology is our software solutions and subscription business. And the gSharp product is actually developed by Ghost Technology. And the third company in our group is gSphere Consulting, consisting of project management services, BAs, testers, those types of project delivery services. A little bit about the Pi Advanced Computing Engine, or PyAce. PyAce has been around for quite some time. It was first released back in 2001 with support for Visual Basic 6. Around this time, the Pi module database had recently been added to the Pi system, and PyAce brought in a capability to create calculations that used the Pi module database as context and allowed you to do things that couldn't be done in the existing calculation engines at the time, which consisted of Pi performance equations and Pi totalizers, both of which were very tag-based calculation methods. And for those of you that can remember back in the day using those, they had a lot of flexibility, but you know, if you wanted to run the same calculation logic in multiple across multiple assets, then you would have to actually create multiple tags for that. PyAce changed that in conjunction with the module database. Version 2 was released around about 2002-2003 with support for VB.NET. The last release of PyAce was actually in 2016, and that was PyAce 2010 Release 2 Service Pack 2, which primarily consisted of bug fixes. No new features have been added to PyAce since about 2012. Last year, on the 13th of July 2020, 2 years ago, sorry, 13th of July 2021, Aviva announced that PyAce would be retired with end of support scheduled for the 31st of December this year. Obviously, we're now fast approaching that. So that leaves us in a position of, for those of you that are using PyAce, where do we go from here? So GTS, with looking at this particular situation, consulting with some of our customers, we made the decision to build a replacement for PyAce. That replacement is called gSharp. gSharp, which is our Ghost self-hosted analytics and recalculation platform, was developed by our company Ghost Technology to provide that migration path from legacy PyAce calculations to a modernized calculation engine, which includes a compatibility library for PyAce specific programmatic functions. I'll talk a little bit more about that as we go through the demo. For those of you that are interested in what does gSharp include, the initial release of gSharp is slated to include the following features. Your analysis scheduling, and remember that for many, ACE represents a great scheduling engine to do all sorts of stuff. With our analysis scheduling, we provide support for clock-based schedules, same as you had in PyAce, natural or event-triggered schedules, meaning that when an event comes into a PyTag, that can be used to trigger a calculation. We've also added cron-based scheduling. For those that are familiar with Unix or Linux and know about cron, you'll be aware that gives us a degree of flexibility in clock-type schedules that the standard period and offset type calculations in Pi don't quite provide. There's also desktop-based management of calculations and scheduling. This is the gSharp administration application, and you'll have the opportunity to see that in action when we go through the walkthrough. We've also developed a programmatic compatibility layer for PyAce. So for those of you that have actually been on the tools and written code, you'll know that you use objects such as a PyAce point, and that belongs to a PyAceNet class module, and often you'll access functions and methods in the PyAce built-in functions classes. In gSharp, we have done our own modernized re-implementation of these classes using the AF SDK. What this means is that for some of the methods and functions, there's a slight change in the signature, where a method might require that you pass in a PySDK-based object, or it returns a PySDK-based object. Then in our programmatic compatibility library, we've replaced those with the AF SDK equivalents. Now, in order to make your migration a little bit smoother, when we ship the first release, we will include a simple code scanner, source code scanner, that will find and highlight for you any of these methods that you may be calling in your code where we've had to make a necessary change to the method signature. This will allow you to be able to more easily refactor that code. What this compatibility library means is that the amount of refactoring required in your code to migrate from PyAce to gSharp, we expect to be fairly minimal. We also are using the asset framework to provide calculation context in lieu of the PyModule database. Hopefully many of you, if not all of you, are using the module database to AF synchronization mechanism that at least synchronizes your module database to an asset framework database. gSharp will allow you to use that synchronized AF database as your source of context for calculations, or if you have a production asset framework database that expands on that synchronized model, you can also use that particular database. It actually is really going to be up to you. The key thing is there's no support in gSharp for module database, nor the PySDK, both of which have been deprecated by Aviva. gSharp also includes highly configurable and flexible logging using a modern .NET-based logging library. And again, you'll get to see a little bit of that in the demo. The first release will ship with manual calculation backfilling and manual recalculation to provide at least that ability to recover or backfill data. The final note is that we support .NET calculations only. Hopefully there's nobody out there still using legacy VB6 based ACE code in ACE version 1. But if you are, you will have to port those applications to .NET first before you can move them over to gSharp. For those that want some comfort that we're not talking vaporware here, this is the basic architecture of the application. I won't go into this in detail, but you can see that it's a highly modularized application. I will make one note here, is that gSharp is not tightly coupled to Pi. The initial release will have that built-in support for Pi, meaning that Pi can be both the source of data and the destination for your calculation outputs, as well as providing context through the asset framework. In the future, we plan to add the ability to be able to interact with other systems, meaning that there will be native connectivity to other data sources and potentially other sources of context. That is something for the future. A little bit about the roadmap. We know that the end of support for ACE is staring us in the face now. It's a little over a month away. We're expecting to release a beta for gSharp by mid-January, with version 1 to be released by the end of, or at this stage, being targeted to be released by the end of the first quarter. Now, let me just add something to that. When we were at Aviva World last month in San Francisco, I had the opportunity to have a discussion with some senior folks with regards to the AF SDK upon which gSharp is built. And we found out at that time that Aviva were finally developing a new version of the AF SDK that would support versions of .NET beyond .NET Framework 4.8, meaning that effectively .NET Core, taking us right up to .NET 8, would be supported when that AF SDK is released. Because of some of the architectural changes in that AF SDK, we've now had to make some late changes and decisions to be prepared for that new AF SDK. And so that's slightly pushed out our expected release schedule. We were originally looking to have a beta version available before the end of the year, but because of some changes that we decided to make before the first release, rather than in a subsequent release version, that's just pushed out our schedule slightly. But at this stage, we are on track to have that beta ready by the time most of you get back from work after the Christmas and New Year break. Just to let you know a little bit about the roadmap, some of the future features that we're currently considering for after the first version is released, things like automatic recalculation, implementing high availability, and separately load balancing, calculation load balancing. We're considering also building some additional built-in analytics functions. The reasoning behind that is we see gSharp as a potential programmatic analytics option for the asset framework. Many of you may recall that when the asset framework came out some years back, that OSIsoft spoke about having two types of analytics: configurable analytics, which we see today in the current asset analytics, such as your expression analyses, etc. And they also spoke about programmatic analytics, which would ultimately replace PyAce. Unfortunately, the dream of programmed analytics within the asset framework seems to have died a little bit of a sad and lonely death. And so we see an opportunity there to be able to expand the capabilities of gSharp. So again, that's one of those things that we're considering. Also under consideration, having a REST API. I don't know how many of you are using the API or actually the web service that comes currently with PyAce, which allows you to pretty much just view what calculations are available. So again, a REST API is something that we're considering, and we'll be looking to get some feedback from our customers about. And as I mentioned previously, because of the modular nature of our application, we'll also be looking at support for additional input and output systems in subsequent releases. Right, that's enough PowerPoint. Let's go and have a look at how gSharp works. So what I'm going to do in this particular part of the demo is start down at the code level, because at its heart, PyAce is about writing code to perform either complex calculations or to be able to, as I know in some of your cases, using ACE to run some fairly complex calculations that not only provide analytics, but other functions as well that are not necessarily directly interacting with the Pi system. So what we're going to do is we're going to have a look at a fairly simple PyAce calculation. Now, for those of you that are not coders, don't worry, we're not going to get down deep and dirty and talk about the code, but I will actually demonstrate what it takes to actually take an existing PyAce calculation, port it to gSharp, and then get it implemented and running and producing outputs. So without further ado, we will, I think we just need to stop sharing, stop presenting, and we will now go ahead and share the other screen. There we go. Okay. So what you see here is a Visual Studio. This is Visual Studio 2013, which was pretty much the last version of Visual Studio that supported the PyAce wizard. One thing I will make a note of is that we are not including a Visual Studio wizard with the gSharp product, but we will be including what we call a developer pack, which will include some Visual Studio project templates, as well as a subset of the assemblies needed to be able to write your calculations. So this is Visual Studio 2013. I've already opened up the project, and this is a fairly simple one. This is a real calculation. It's one that I wrote probably about 10 years ago for a customer, and just prior to Asset Analytics. Today, this one probably could actually be migrated to Asset Analytics, but for our purposes, it will provide a great demonstration. So you can see in the top of the code that we're importing two assembly references, and these references are the OSIsoft PyAce net assembly and the OSIsoft PyAce-DK. So these were pretty much core to a PyAce calculation. And the import statements here just show that we're using those references. A couple of key things here. We're inheriting this PyAce net class module. That gives us access to certain methods and functions that our user code requires. And you can see that we have a PyAce point. I've got two PyAce points. One is the input for this calculation. One is the output. And then there are a few built-in functions. For example, in our try catch block, we're using the log PyAce message function in that built-in functions library to be able to log a message indicating that there was an error in our calculation. Now, this particular calculation has two modules that are exposed in PyAce. One that gives us the daily averages of these SO2 calculations or concentrations, and one that gives us the daily and the hourly averages. And so the code for these is almost identical, but we're calculating on a different time basis. And as you can see, we're using the same references. What I'd like to do now is switch to Visual Studio 2022, where I've made a duplicate of this particular calculation solution. And in Visual Studio 2022, you'll see that we've got the same two modules, the hourly averages, the daily averages. We're using the PyAce assembly as well as the PySDK. And you can see that things like the PyAce point resolve to that OSIsoft PyAce assembly. Now, we're going to take this particular code and we're going to go ahead and migrate it into a gSharp assembly. So the first things that we want to do here, and one of the nice things about the later versions of Visual Studio is that they make it a little bit easier to find information. So here again, you can see those two key references, the OSIsoft PyAceNet assembly and the OSIsoft PySDK. We're going to remove both of those because we don't need them for a gSharp assembly. Notice that having removed those, that a number of these things now can't be resolved. These objects and methods can't be resolved. So what we do is we're going to add references to the gSharp assemblies, including the OSIsoft AFSDK. Now, all of these assemblies that you will need to reference, these will be automatically referenced in the project and solution templates that we provide as part of our developer pack. For those of you that will be going through this process of having to port calculation code, again, in the developer documentation that will ship with the product, this information will be available to you. So I've added all of those references. We now need to change these import statements up here. So the key thing that we want to change here is that we are going to change to our Ghost assembly with the gSharp namespace and the pi.ace reference. And instead of the PySDK, we're going to use the OSIsoft AFSDK. And in this particular case, we need to use the asset namespace because I will show you when we get down to the relevant code. Having added that ghost.gsharp.pyace import statement, you can see now that the PyAceNet class module has re-resolved. And if you can see that tooltip, you'll see that it's now referencing the gSharp assembly. Likewise, the PyAce point is also now referenced from our assembly. And this is that compatibility layer that we spoke about, where we've re-implemented the PyAceNet module class using AFSDK. So all of the public methods and properties of PyAce point plus the PyAceNet module and the PyAce built-in functions, all of those have been re-implemented. And so this is why we say that the amount of work required to port your code, we expect to be fairly minimal. Now, the other things that we need to change in our code, again, Visual Studio is nice and helpful. It highlights for us the areas that still need to be fixed. Now, in this particular code, let me just close that. In this particular code, I used a common class that would get the source values from the PyAce point and would return those to my caller. So in this particular common code, I also need to make a change to the import statement, which will be ghost.gsharp, and it will be the PyAce component. And finally, also, I need to bring in the AF-SDK. Okay. What we need to change down here is this get source values function used to return a PyValues collection from the PySDK. That's now going to return a new object that we've introduced, which is called PyAce values. I'm not going to explain that one now, but that's covered in the developer documentation for those of you that may need to interact with that collection. At the end of the day, it is actually just a collection, a special collection of AF value objects. Now, when we retrieve the values, and this values method is from the PyAce point, and it requires that there are three parameters passed: a start time and an end time, and what they call the boundary type constants. And the boundary type constants was a PySDK enumeration. So our version of the boundary constants is based on the gSharp implementation. Let's change that one, and we will use the auto method. So that will take care of that little piece of code. If I go to my hourly averages, where I've called this method from that common class, get source values, those source values are being returned to us as PyAce values. And so as I iterate through that collection to do something with it, I actually now just need to change that to the underlying type, which is an AF value object straight from the AF SDK. The last item that I need to change in this particular module is where I'm calling the log PyAce message. As a developer, one of the real bugbears that I always had with this method was that when you specify your message level, you always had to use this fully qualified path of the namespace, osoself.py.ace.message level, regardless of the fact that we had an import statement for that namespace at the top of our code. In the gSharp implementation, we can just get rid of that altogether, and that will resolve to the appropriate message level. And again, those message level enumerations are exactly what you would be using in your existing PyAce code. So that particular module is now complete. We'll make the same changes in the daily averages, and just to make it a little bit easier, we'll do a copy paste of those. And again, we will change this one to represent AF values in our PyAce values collection. We will update the reference for the message level. There are no more errors in that code. That code is now ready to be compiled. Now, as I said, in PyAce, you had a wizard where you had to use that wizard to create a new calculation, edit the calculation, debug it, test it, ultimately compile it. In terms of compiling this particular code, all I actually really need to do is just go ahead and use Visual Studio's build option. So we can see at the bottom the build succeeded. What we now do is we take that, the compiled assembly, and we're now going to deploy it to our gSharp server. So that compiled assembly the actual assembly, all of these are the various references that ultimately gSharp uses within the server. The one that we're interested in is just this one here, the SO2 concentrations. I'm going to copy that assembly and take you to my gSharp server. Now with assembly management, gSharp is quite different from PyAce in the fact that we use a staging folder. In fact, let me take a step back there. I have missed an important step. One thing that I should have mentioned with gSharp is that we use assembly versioning to manage the assemblies in the server. So it's possible to deploy an upgraded assembly, effectively, from our perspective, hot swapping it. So there's no need to shut down any modules or assemblies in the ACE manager, shut down the scheduler to swap out the actual assembly files. We do that live. But the way that we do that is that we make use of, there we go. We do make use of versioning of our assemblies. And so we're going to set the file version for this as version 1 of this assembly. Save that. I need to build that one again because I do need that assembly version. Let's take that assembly. Now we'll deploy that to the gSharp server. So this location that I've deployed it to is what we call our staging folder. Now, just to let you know, PyAce is running on this server, and the calculation that I've just deployed is this one here, the SO2 concentrations. There are five contexts for the daily and the hourly averages. So I have five monitoring stations that are running those contexts. And as you can see, these are all running and producing data outputs. What we're going to do is we'll start up the gSharp administration application. And I currently have one calculation assembly running, and that's this time to overflow. And this one has some 500 odd contexts currently running. What we're going to do is we're going to add a new assembly to our gSharp server. So I click on the plus button, and this will open up a dialog that's looking at my staging folder. In the settings for gSharp, I've specified where that staging folder is. I'll show you those settings shortly. So here you can see that there are two assemblies that it's noted as being gSharp assemblies. There is my SO2 concentrations, tells me it's version 1, and that it's a new assembly. It's not been registered. There's also a copy of that time to overflow calculation, and it's showing up as a replacement because the version that you see in the staging folder, 1.0.26.0, is the same as the current version that's running in the server. So what we're going to do is we're going to select the SO2 concentrations assembly. You can see that we've detected the two modules, the daily averages and the hourly averages, just like we would in PyAce. We'll click OK. And now there's a couple of things that I need to do to get this assembly running. The first is that in both the daily averages and the hourly averages module, gSharp has detected that there are 2 data points in each one of those. These are those PyAce points that we're working with. There's the 24-hour average concentration and the 5-minute average. So in our calculation, the 24-hour average is the output. The 5-minute average is the input. Likewise, in the hourly averages, we have the 1-hour average as our calculation output, and the 5-minute average is the calculation input. What we need to do here is we need to map those data points to an attribute in our asset context. So what I'm going to do is bring up the point selector. Now, we are aware at the moment there's a minor issue with that, so I have to actually close that and reopen it to get it to find the database. We are working on this one. It will be fixed by the release. So in this particular case, the AF database that I want to connect to the AF server, the AF database, which contains my contexts for this calculation. And here you can see I have my 5 SO2 monitoring stations. So I'll just take the first context. And the key thing that I'm looking for here is the tag attribute, or the attribute mapped to a pi tag, that will provide the input from, in this case, my SO2 24-hour average. So that's an output. Now, in this database, I'm actually going to use this daily cumulative concentration version 2, because version 1 has the tags that PyAce is writing to for the same calculation. So I'll click OK for that. And then I want to do the same for the 5-minute average. This is mapping my input. So there's my 5-minute average concentration. Now I can actually take that and just copy that and paste it down into here rather than searching for it again. And likewise for my 1-hour average concentration, we'll go ahead and select the appropriate output tag. Okay. So we will save those. Now it's time to actually create some contexts. So what I'm going to do is expand that assembly, and we'll start with the daily averages. So there are no contexts, as you can see. So what I need to do is click on the plus button and add a new context. So the path is now the full element path in the AF database for that context. And so in this instance, I want to start with station 1. So I'll select station 1. Notice that that brings in that full AF path, and it also applies a name being the name of the element. You can change that if you wish without affecting the mapping to the context itself. We have our points, the SO2 24-hour average and the SO2 5-minute average. Now what I need to do is add a schedule to this context. So I'll click on the schedules, and here you can see that I have 4 different schedule options. I can do a natural schedule on the 24-hour average or the 5-minute average. Now in this case, I'm going to use the 5-minute average because that is defined as our input tag. See also that there is the ability to add a clock schedule or a cron schedule. So we'll start with a natural schedule on the 5-minute average. We need to save that. And notice also now that we have that in place, that the points have resolved to the appropriate attribute in the context of station 1. Now, one thing that we did add to gSharp that you can't do in PyAce is the ability to add multiple schedules to a context. I'm not going to add another schedule, but I might say, well, I also want a clock schedule, and the clock schedule has both an interval and a start time. So effectively your period and your offset, as in PyAce. So I could say I want it to run on an interval of every, let's say every 12 minutes, just to be different. And I want it to start at 12 minutes past midnight. Okay, we'll save that. And I can now simply go ahead and start that context. So that context is now running. If I want to add my additional contexts, I can go ahead and add those additional stations. I add a schedule for that one. Again, we'll just do a natural schedule on the input tag. And so we'd go through all 5 stations. Now, one of the things that we will be looking to ship with the first release, and something that we're currently working on at the moment, is a small utility that will allow you to migrate the context definitions that you have in PyAce, so that in the instance where you have something like 500 odd contexts or more, we don't want to have to go through this process of doing the individual stations or context, setting up their schedules. So we are looking at the ability to be able to have some kind of bulk context definition importer and allow you to remap those contexts to an appropriate asset database. So those two calculations are now running, and I could rinse and repeat for the hourly averages. Again, go ahead and add contexts. I won't go through that. You've seen the process a couple of times now. What we will have a look at is some of the logging available. So this is the server log. And here we can see that, for example, where we first imported the assembly into gSharp, we've gone ahead and created the modules. These calculations, these are user messages coming from, in this case, the time to overflow, just simply telling me that there was an insufficient number of samples for that calculation. Okay. Here again, we can see as we've created the context for the SO2 monitoring station, registering the natural schedule, and also registering the clock schedule for that particular context. Likewise, registering the natural schedule for our second context. Now with logging, the logging is highly flexible, as we mentioned in the feature set. One of the areas that we're currently working on to get finished for the first release is filtering of your logging, so that you can filter using a number of different criteria to potentially filter out some of the noise that you see in the overall server log. In the settings for gSharp, here you can see that we specify our assembly staging folder. That can be set to whatever you wish. You can also set the logging levels individually for your calculations. So there's a number of different log levels. Going down to things like trace is going to be highly verbose. It's the sort of thing you'd only do if you need to get that level of detail for troubleshooting. Typically, all the calculations that you import will have the info level. We use the nlog logging library. It's quite a common and popular .NET-based logging library, and OSIsoft Aviva have been implementing that into many of their applications over the last few years as well. You can also set the logging levels for different aspects of the server. And again, if you need to have different levels of detail for different components, or you can actually make a global change for all of the server. Likewise, there is a global option to set everything for your modules. That is really the main parts of looking at the gSharp administration. One thing that I will mention, like PyAce, it's possible for you to start and stop your calculations at different levels. Notice here that for these contexts, that there's a pause button at the context level. So I can pause the entire context, or in the case of my schedules, it's possible to even pause just an individual schedule within a context. So I might want to turn the clock schedule off for some reason. Okay. If I was to pause the entire context, what we should see is when we restart it, it remembers that a particular schedule was stopped, and so it won't automatically restart that. Likewise, if we choose to, if we were to choose to pause a given context, and now we want to, for some reason, we need to pause the whole module, we can do so. When we restart it, gSharp will remember that, in this case, SO2 Station 2 was already stopped. It's not going to restart it until we're ready to do so. And you can also do that at the assembly level. So again, you can stop individual modules, which will stop just that module, or you can stop the entire assembly. As I said, deploying an update to the assembly, you can bring in this one. So notice that both of these now replacement because they're deployed. If I had one of these that showed up as an upgrade, which means that it's got a higher version number than what's been registered, I can simply select that, import it, I don't need to stop anything. The gSharp server will actually manage effectively the hot swapping of that assembly, so that the new code that you've deployed or the changes you've deployed will automatically take effect at the appropriate time. Okay, I think that's enough for the demo at this point. Just a little bit of other general information. gSharp uses Microsoft SQL Server as a backend for storing context information and logs. And so part of the infrastructure requirements when you deploy gSharp is access to a SQL Server. Now, because most people will be using PyAsset Framework, which requires SQL Server, we anticipate you being able to create the gSharp databases on that same infrastructure. I'm going to say pause the demo there now. We have about 15 minutes left of our webinar. So what I'd like to do is now open up for questions and answers. Anything that you would like to know that hasn't already been addressed, or if you want to revisit the previous information, the floor is now open. So if you'd like to type your questions into the meeting chat, and we will be able to answer those. So please, the time is open. Okay, question from Mark with regards to cost. No, it's not too early to start talking cost. gSharp will be licensed on a subscription basis, and we're looking at an annual subscription of a bit under $10,000 per year. That's for a production instance of gSharp. Should you wish to deploy non-production versions, so if you want to have gSharp in dev, test, and production, your non-production gSharp licenses will be 40% of a production license. So similar to the licensing model that Aviva uses for the Pi system. But yes, you're looking at a bit under $10,000 a year for a production instance. Okay, question from Christine. We haven't released the beta version yet. We were hoping to have the beta ready by the end of the year. That's been pushed out slightly. So at this stage, we're expecting to have the beta ready by mid-January. Anyone that is interested in being a beta tester, you can email me directly, or you can go to the Ghost website. The Ghost website is I've just dropped that into the chat. It's at ghost.site, S-I-T-E. And on the gSharp page, there is a link that you can click on to sign up as a beta tester. Otherwise, feel free to email me directly. Most of you will have my email address. Feel free to email me directly. We're more than happy to have you beta tested for us. Okay, so a question from Callum. He's asked, is there any option to define module contexts using AF templates, e.g. to auto-add individual contexts for instance of an element rather than manually adding them? Yes, we're actually looking at that at the moment. Obviously, one of the superpowers of Asset Framework is the fact that it uses templates. And because we're all following best practices and using templates for our asset models, we fully expect to be able to have something that will allow you to select a template and bulk add context. That's an area that we're still working on and trying to nail down what the final functionality will be, but we're certainly looking to leverage that template capability. Okay, another question from Mark. Anything we're currently doing in ACE, such as file imports, data manipulation, will still be fine? The answer is yes. The code as you've written should still work as written. So if you're interacting with the file system, if you're doing any kind of data manipulation, the only changes that we envisage, as I said, is once you've referenced the gSharp assemblies instead of the ACE assemblies, where you need to make hopefully minor changes to your code, everything else will still run as previously. One other thing that I will mention is that if any of you are still using your ACE assemblies targeting version 2 or version 3.5 of the .NET Framework, we do recommend retargeting them to .NET Framework 4, ideally something like 4.8. gSharp will support that. It also gives you the ability just to make use of a slightly more modernized and secure version of the .NET Framework. Okay, I'm not sure if there are any other questions. Possibly one more. While we're waiting for that question to come through, this webinar has been recorded. Once we've posted it and made it available online, everybody that has registered for the webinar and attended will send a follow-up email. I will send a follow-up email with a link to the recording, so that if you want to review it later on, if you want to be able to share it with colleagues or somebody else. And of course, I do know most of you personally. Most of you have got my contact details. So again, if you have any other kind of questions, feel free to contact me directly. I can see a couple of new questions that have come through. The first one, what are the limitations on the number of assemblies, modules, contexts? We don't believe that there are any limitations on that. We are yet to do some fairly high-scale testing. At the moment, my particular demo system, I have one assembly running 520 odd contexts. It seems to be running fine. We spoke with a customer in San Francisco last month at Aviva World, where they're running around 18,000 calculation contexts. Looking at something like that, we would expect that to handle that kind of load, likely you probably need to run a couple of instances of gSharp to handle that. We're yet to do some significant scale testing that will be happening hopefully between now and the release of the beta. So I'd like to say that there are no limitations on the number of assemblies, modules, contexts. However, physics being the thing that gets us, there will be upper limits on how many you can run on a single machine, unless of course you have the ability to up things like the memory, the processor count, etc. But for large counts, you're likely going to have to look at maybe splitting it out into multiple instances. A form of load balancing, I suppose, but they will each be standalone instances. Next question that's come, what's the advantages of gSharp over moving the programs to standalone services? We see the key advantage being, one, you don't have to write the code to implement a Windows service or handle your scheduling. One of the great advantages of PyAce was it had the scheduling mechanism. It ran as a service. It had all of those software infrastructure bits set there for you. gSharp does exactly the same thing. And so rather than having to do potential significant rewrite of your applications to move them into a standalone service, as you've seen, and I'll be the first to admit that the code that we used in the demo was fairly simple, but we still expect even in more complex code, and I've seen some of the complex code that some of you are running. I've written some of it. We still expect it to be a fairly straightforward process of migrating to gSharp. So we see the key advantage there just being the cost of migration would be significantly lower than having to rewrite things and maintain those things yourselves. Okay, another question coming through. Okay, any thoughts of a wizard interface for adding inputs and outputs to calcs? We have thought about that. We don't believe that there's any value in us adding a wizard to the not for Visual Studio. If you're looking at something outside of Visual Studio, would love to know more about what you're thinking. And Mark, I'm going to be up your way next week. So I would certainly be happy to have a chat with you about what you might be looking for there. And I extend that invitation to anybody. Anything that you think that you would like to see based on what you know of your current usage of ACE, we're more than happy to take your suggestions, look at what we think adds value to the product. And as I said, you know, we have a roadmap to take us beyond version 1. I've given you some high level details of that. And of course, for those that are interested, I'm happy to periodically share our roadmap updates as they progress. So hopefully that answers the question, Mark. And as I said, we can certainly talk more about it next week when we catch up. So folks, we've pretty much reached the end of our available time for this session. Thank you so much for your attendance. It's been a pleasure speaking with you. It's been a pleasure showing you gSharp. As I said, you have my contact details. Feel free to contact me should you have any further questions. And for now, thank you and enjoy the rest of your afternoon.